We begin by looking at the modern business environment and the way in which production methods have changed. Historically, when mass production first was introduced after the Industrial Revolution, everything centered around high volume and the emphasis was on low unit cost outputs. With this came Henry Ford's traditional quote, "You can have any color you want as long as it's black," referring to his Model T Fords as they rolled off the production line, everything identical. However, in recent years, many changes have taken place in the nature of the world economy and technology, as well as demand and manufacturing practices. Technology has influenced the world through the internet, giving consumers more choice and more information about potential products affecting demand, but technology has also been introduced into the manufacturing process, making customization of products easier and more commonplace.
So, in the modern world, what sort of environment do businesses work in? In lecture example 1, we've got 4 statements. So what you've got to do is have a look to see which of these correctly describe the features of the environment the businesses now have to operate in. So, pause the presentation, have a read through the 4 statements there, and see whether or not you think that they're relevant. When you're ready, press play. Okay, statement A. Well, hopefully you realised that this was incorrect. Businesses don't only compete on cost these days, quality is perhaps more important, and reliability, and also customization, giving the customer exactly what it is that they need. And because of that customization, it means that it's not true that production is mainly done in large batches with emphasis on standardization. What we're going to try and do is produce exactly to specifications required to us by each individual customer. And that means that there's going to be much more small batches and less emphasis on standardization. It certainly is true that customers are more demanding and therefore there's increased emphasis on quality and reliability of output. So C is correct. And the final statement is also untrue. There isn't less competition, there's actually more competition. We've now got the internet, so there's lots of online competitors as well as competitors that are just in the same area as you on a geographical perspective. It is true, however, that the business is more globalized. There's more companies selling the same goods and services, and they're all dispersed internationally. They're all over the world. So the only true statement really out of those 3 is C. In this section, we're looking at a philosophy called world-class manufacturing. Now, world-class manufacturing is an approach, or really more of a philosophy, that was accredited to Toyota in the late 1970s. It's really a response to increased competition in the USA car market. And what it focused on is a number of features. So let's have a look at these features. First thing was quality improvement. If they were going to compete, then they had to concentrate on quality. It also gave birth to just-in-time base production. And we're going to have a look at that in more detail later on. But it means that really we're just going to produce in response to customer demand. We're no longer going to produce just for inventory, and therefore we're going to have to streamline our process and be much more flexible. We're also going to involve our people much more. So there's going to be more of an emphasis on teamwork and empowerment of employees and training of employees. And because of that flexible approach, it means that we can adapt to any customer requirements. So we're going to see what the customer wants, and then we're going to try and respond to that rather than the other way round. So world-class manufacturing really encompasses everything that just-in-time and total quality management offer. You could say it kind of gave birth to them in a way. Now, the main benefits of world-class manufacturing are as follows. First one is that there's very quickly improvements in production efficiency. And what that means is that standards become out of date very quickly. And if you think about techniques such as standard costing, then that has quite a big implication for management accountants because we need to revise our standards all the time. It also means that we can achieve competitive advantage. We can do things better than anybody else. And all of these good things are bound to lead to long-term profitability. So it's in a business's best interest to try and approach world-class manufacturing in the same way as Toyota did in the 1970s.
One of the ways in which technology has been incorporated into design of products is through advanced manufacturing technology, also known as AMT. This is a collective term then which encompasses lots of different practices and techniques, all of which make use of this increased technology and specifically computer systems. You need to be aware of 4 types of advanced manufacturing technology. Computer-aided design, which uses computer technology to help design the products at the early stages of the product life cycle. This is followed by using computers to assist the manufacturing process. In many modern factories and production processes, you will see that computers have replaced individuals. Many of the processes which were conducted manually, for example, putting the lids onto bottles and putting those bottles of milk into boxes, is now conducted by machines. These machines can operate faster than humans and with greater degree of reliability in many cases, because checks can be built into the machines to check that all of the tasks have been performed to an adequate standard. Flexible manufacturing systems also enable companies to increase that customization of their products and therefore to satisfy the consumers. The final type then we have is the electronic data interchange. Electronic data interchange then is the computer-to-computer exchange of vast quantities of information. So aspects from one part of the process can be fed into another automatically. These techniques then and other innovative computer equipment are used by world-class manufacturers to give them an edge, to give their competitive advantage. And they have a big impact on the way modern manufacturing companies operate. This picture shows the Arla bottling plant for milk in Aylesbury, and I think the photograph is a very good representation of what advanced manufacturing technology looks like in practice. In this picture you can see then that this milk is being bottled at the rate of 4.7 seconds per bottle. That's how long it takes for the process to happen. And you can see that there's a real absence of people in this factory. Machines instead, the production lines automated, and robots in lieu of humans. Obviously there are still people working there, but a vast reduction in the number of people than previously needed to run a bottling plant like this one. So we've got in here then examples of technology which are enabling the cost reduction and the increased flexibility to occur.
Total quality management then is a business philosophy, and it's aimed at improving quality. Now, there are a number of key principles in total quality management that you really need to learn. First one is get it right first time. This idea really is going back to the idea that if we actually prevent mistakes happening, then it's going to cost us less than correcting them if they occur. We'll look at that a little bit later when we look at something called conformance and non-conformance costs. The second is this idea of continuous improvement. So never being satisfied with the current achievement, and it's always possible to improve performance. Now, this has some implications for things like motivation, because if you are being judged on what are often ideal standards because we're striving to always improve, then sometimes that might be quite demotivating for staff because they never actually get there, they never actually achieve that perfection. It also has some implications for our budgets because, again, if we're going to try and set what we call stretch targets, then that's going to be quite difficult to actually plan using those targets because we know that we're not really likely to achieve those. So we're going to have to think carefully about our target setting and how we actually use that going forward. The third is that we design for quality. And designing for quality means that we're actually going to design in the actual idea that we're going to get things right first time. So sometimes that might actually be to involve, for example, suppliers in our design process. So how can we do it? Well, what we might do is look at the number of parts in a product. You'll probably know from experience that the more parts something has, then the more likely it is to go wrong. So if we can reduce the number of parts, then that means that we've got clearly less things to go wrong. We're also going to use components that are common to other products in the organisation. So some sort of flexibility where we can actually use common components across different things. And also improve physical characteristics to meet customers' needs. Now, we might have some functions that actually go into products, things that maybe some products do, that actually customers don't really need them at all. So we're actually going to see what customers require from our products and services, and we're going to improve the characteristics of those so that we're actually supplying what the customer wants. And we're going to build that in at the start of the process rather than later on. Dyson's a good example of this because what they did is they had their vortex technology when they built their vacuum cleaners. But what they also did is they reduced the number of parts in their products. Now, not only was this less to go wrong, it also meant that there was less suppliers and therefore less deliveries and therefore less cost. Now, with those three principles in mind, then, these are the goals of total quality management. So, gaining competitive advantage via continually improved quality. So, always being one better than the competition. Continually reducing the cost of providing that enhanced quality. So, always looking to ways to improve, and that is going to have an effect on our profits. It also means by involving everyone in the organisation that we can innovate, and that is going to improve motivation, more people to give ideas, and that innovation is going to feed into our competitive advantage. And then finally, to provide first-class customer service. So we're not just stopping at the point when we've provided the product or the service to the customer, we're actually going to keep it up. We're going to make sure that we've got excellent after-sales, excellent delivery, etc., etc. So in this total quality management environment, one of the things that we want to do is to monitor very carefully our quality costs. What we want to try and do is minimize our cost of quality. And in order to do that, we're going to actually monitor very carefully 4 different categories of cost. Now we're going to split these into 2. And the first is what we call cost of conformance. So think of this as the cost of complying with our own quality standards. Okay. Now the cost of non-conformance is where we fail to comply with our quality standards, and because of that, something that is faulty ends up happening. All right, so we end up with some faulty goods. Now these are quite high level categories, so we're going to break them down a little bit lower. And the first category is prevention costs. So prevention costs is the cost of preventing quality errors. So an example of that might be the development of a quality control process. Also in costs of conformance, we've got appraisal costs. Now appraisal is anything to do with checking that we've met our own standards. So that might be, for example, inspection costs. When we get onto our costs of non-conformance, we can split these into internal failure costs and external failure costs. And the key difference there is whether something has yet reached the customer. Now the internal failure costs then are things like rework of substandard products. It's yet to involve the customer, but it doesn't conform to our quality standards. So it's going to include things like wastage. However, when it gets to the customer, it becomes an external failure cost, and the customer's now involved. Now, some of these costs are really quite difficult to quantify because they may be things that are to do with lost goodwill. So maybe the customer tells all their friends never to buy goods from us ever again, and that's going to mean that we're going to lose sales in the future. But there might be things like warranty claims or cost of replacement products. Okay, so in lecture example 2, we've got a table. We've got on the left some conformance costs, and on the right we've got some non-conformance. So see if you can go down the list of different costs there and categorize them either as prevention, appraisal, internal or external failure costs. So pause the presentation, and when you're ready to go through the answer, press play. Okay, so re-inspection costs then are an internal failure cost. So this is internal within the business. We've had to re-inspect something because it's already not met our quality standards. The loss of goodwill I mentioned before, that's an external failure cost. Quality engineering is actually a prevention cost. Inspection of goods inwards is an appraisal cost. It's to do with checking. And a customer complaints hotline, well, customers are only going to complain if there's something wrong, so that's an external failure cost. Performance testing is again a form of checking, so that's going to be appraisal. Training is prevention, so if we've got well-trained employees, then hopefully they're not going to do things wrong. Sale of substandard goods is internal failure. So what we're doing there is we're actually selling goods off more cheaply than we would otherwise do. Maintenance is prevention. And then finally, wastage due to errors in processing, and that's internal failure. So in this total quality management environment, one of the things that we want to do is to monitor very carefully our quality costs. What we want to try and do is minimize our cost of quality. And in order to do that, we're going to actually monitor very carefully 4 different categories of cost. Now we're going to split these into 2, and the first is what we call cost of conformance. So think of this as the cost of complying with our own quality standards. Okay. Now the cost of non-conformance is where we fail to comply with our quality standards, and because of that, something that is faulty ends up happening. All right, so we end up with some faulty goods. Now these are quite high level categories, so we're going to break them down a little bit lower. And the first category is prevention costs. So prevention costs is the cost of preventing quality errors. So an example of that might be the development of a quality control process. Also in costs of conformance, we've got appraisal costs. Now appraisal is anything to do with checking that we've met our own standards. So that might be, for example, inspection costs. When we get onto our cost of non-conformance, we can split these into internal failure costs and external failure costs. And the key difference there is whether something has yet reached the customer. Now the internal failure costs then are things like rework of substandard products. It's yet to involve the customer, but it doesn't conform to our quality standards. So it's going to include things like wastage. However, when it gets to the customer, it becomes an external failure cost, and the customer's now involved. Now, some of these costs are really quite difficult to quantify because they may be things that are to do with lost goodwill. So maybe the customer tells all their friends never to buy goods from us ever again, and that's going to mean that we're going to lose sales in the future. But there might be things like warranty claims or cost of replacement products. So how do we measure performance in this modern business environment? Well, we've already mentioned that traditional variance analysis isn't appropriate due to the fact that not only are standards becoming out of date very quickly, we're also trying to continually improve. Variance analysis and standard costing has much of the emphasis on just hitting the standard and not doing anything to actually surpass it or to get better than the standard. And that clearly isn't in line with the ethos of a total quality management environment. So what we do need are some alternative measures of performance, and these are mostly non-financial. So we've got, for example, measuring incoming supplies, monitoring work as it proceeds, and measuring customer satisfaction. Now, you should be prepared in the exam to think about measures of performance given a different scenario. Let's practice this in lecture example 3. What we've got to do here is to identify a suitable non-financial quality measure for each of the following types of business. Now this is in addition to a cost of quality report, which will actually detail the costs involved in quality management. But let's think about non-financial measures now. So pause the presentation, have a think about those 3 businesses given there, and see if you can come up with a non-financial performance measure for each of them. When you're ready, press play. Okay, so the mobile phone shop on a busy high street. Maybe we want to measure the number of faulty handsets returned per week. A top-end restaurant. Well, a top-end restaurant may be the number of complaints, maybe per service. And then thirdly, an accountancy training provider. Well, maybe we get some customer feedback, some feedback from our students, and we have some feedback scores. So maybe we have some average feedback scores over a period of time, maybe 1/2 of the year. There's lots of other measures that you might have come up with as well. So far we've raved about total quality management and said it's wonderful. However, there are some problems in implementing total quality management within an organisation, and you should be aware of these as well. I've already mentioned that it can be demotivating because in reality people cannot achieve perfection. There's also some barriers to participation. Even though we want there to be an emphasis on employee empowerment and teamwork, not everybody can be involved with total quality. Sometimes people have to just get on and do something fairly menial. Now, let's just say that there's a standard to answer the phone within 3 rings. That's actually quite an important thing, and it's actually going to achieve quality in quite a small way. But it's very hard to convince somebody that's been told that they have to answer the phone within 3 rings that they're actually doing something that's going to change the organisation. So it's quite hard to actually get everybody involved. It is a case of changing the culture, and changing the culture of an organisation can't be done overnight. It takes a long time. The other thing is it relies heavily on the quality of suppliers. Now, total quality management links very much into our next topic, which is just in time. So we'll look at the quality of suppliers when we look at just in time. Okay, let's have a look at just in time. Before we look at just in time though, let's just go back to traditional theory, just briefly. You may have studied before in your studies something called economic order quantity. Now, economic order quantity focused very much on production and inventory building. If you remember, there was a formula. You worked out an economic order quantity, which basically took into account the cost of holding inventory. So it assumes that we are going to hold inventory. It also takes into account the cost of ordering. So clearly every time we place an order, it's going to cost us money. And it also takes into account annual demand. And what it comes up with is basically the most economical quantity that we're going to order at any one time in order to minimize both these holding costs and these ordering costs in total. Now, when we use economic order quantity, we also use what we call reorder levels. And the reorder levels are that we order when inventories fall to a predetermined level. And all of this assumes that there is going to be a substantial amount of inventory within the business. Now, just in time works in contrast to that. And just in time is what we call a demand pull system. In other words, we're only going to actually either produce finished goods or buy units of inventory as they are required by production, or we've actually got demand for the finished goods from the customer. So we're going to break it down into just-in-time production and just-in-time purchasing. So they are quite different, and sometimes questions will only focus on one particular aspect of just-in-time. But they are both related to this idea that we've got a demand pull system. Now, one of the key things about just-in-time is the elimination of non-value adding activities. And one of those non-value adding activities is inventory holding. So what we're going to aim to do is hold ideally 0 inventory, or at least very, very little inventory. Sometimes we might have a very small buffer, but ideally it's going to be 0. In just-in-time production, we're actually going to make sure that we've got much more flexible, rapid and cost-effective production. If you think about it, if a customer puts in an order in a shop, they don't want to wait too long for their delivery. So we've got to be very, very efficient and effective at getting that particular product made and delivered to the customer in the shortest possible time. So let's think about just-in-time purchasing. So previously then, what would have happened is that goods are delivered and they get put into the warehouse as raw materials, and then they go to the factory when they're required for production. Just-in-time basically gets rid of that warehouse, and it says, well, as soon as the goods are delivered, they're going to go straight to the factory. So we're only going to buy in raw materials as we need them, and that means there's going to be no inventory. Now, the usage of our raw materials is exactly going to be matched with the delivery from the supplier. So there is going to be a lot of reliance upon suppliers. And sometimes even the IT systems might be connected so that this can be an absolutely seamless process. So what kind of elements are there to just-in-time purchasing? Well, the first 2 points there are really about deliveries. There's going to be lots of deliveries. If we're only going to order as and when we need the raw materials, then we have to have a lot of control over the timing of deliveries, and there's going to be frequent deliveries. Now this has an impact on the order costs, because although our holding costs are going to go right down, then our order costs are actually probably going to go up. There's also going to be a lot more importance on selection of suppliers. We're going to probably have closer relationships with just a few key suppliers that we're going to enter into long-term contracts with. And the emphasis is going to shift from inspection to quality assurance. So hopefully our inspection costs of goods inwards are going to go down, because we haven't got time to inspect goods as they come into the organisation. They're going to go straight to the factory. So we need quality assurance from our suppliers that the goods that they supply are going to be of good quality, that we can be sure we can just use them straight away. Now for that we may have to be prepared to pay an increase in our prices to our suppliers. In lecture example 4, you've got to complete some sentences about JIT purchasing by populating the paragraph with the words from the table. So pause the presentation, have a go at putting the appropriate words into the right places within the paragraph, and then we'll go through the answer when you're ready. So press pause and press play when you're ready to go through it. Okay, so let's go through this paragraph. So JIT purchasing means that goods are purchased from the supplier only as they're needed for production. In order to ensure that there are no production delays, suppliers must be able to provide raw materials of a high quality. So quality is the word that we want in there. And timeliness of delivery is essential. As raw material stocks will decrease dramatically, holding costs will be greatly reduced, as will the risk of obsolescence. A company operating JIT purchasing will also form relationships with a few key suppliers, and to ensure the necessary quality standards, an increase in price may be necessary. Just before we move away from this lecture example, let's just mention one or two other things. We talked here about holding costs. Now, holding costs cover a whole range of things like insurance, maybe storage is necessary at maybe things like a temperature, like refrigeration, so all of that cost would be saved. Obsolescence is also a type of holding cost, really, because it just means that the goods are going to either go out of fashion, or quite simply they're going to go off if they're perishable. We may have things like security as well. And of course we've got the cost of things like premises, so rent and rates. So holding costs, there's quite a few things that go into that category. Okay, so let's look at JIT production. Now, in the past, if we've got a customer that places an order, then we can normally just take that order straight from the warehouse and we can give that to the customer straight away, whatever the particular item is that they want. What we might then do, of course, is to manufacture to top up our stock, and that's going to take place in the factory. Now, under JIT production, that's not going to happen because there's going to be no stock in the warehouse. So the customer places the order, and then there is a demand pull for us to actually manufacture that particular item. Now, we don't want the customer to have to wait too long for it, so that manufacturing process has got to be very, very effective and efficient. So how do we go about doing it? Well, there's a number of elements. The first thing is that our work in progress and finished goods inventories should be 0. Okay, so we shouldn't hold any stocks of those, and of course that means that we've got this reduction in our holding costs again. So holding costs of finished goods this time. We also need our lead times, which means the time it takes to receive our raw materials, but also the time it takes to deliver these goods to the customer, and our setup time. So setting up machinery to manufacture needs to be as small as it can possibly be, so we have to decrease those. What's really, really important though is this link with total quality management, because we can't afford to get things wrong, because that's going to result in delays to the customer. So we need there to be 0 defects, and in order that we can continue to provide quality goods, there needs to be continuous improvement. So always looking to improve the way that we do things. Now, the workforce need to be flexible. Think about working hours. Now, if we're only going to produce when there's an order, then that might be not for a while. So we've got to accept some idle time, and we've also maybe got to build in to contracts of workers the need to work maybe essential overtime to actually make sure that these goods are produced when they need to be. We might also have them flexible in terms of multi-skilling, so getting them to do more than one job, because it might be that maybe different skills are required for different products, and as demand varies, then they might have to be quite adaptable. Quality control as part of the production process, so we build it into the production process, and that means that that is actually going to decrease the time it takes and hopefully result in lower lead times. Production to order, and also detection of production problems as they occur. So this means that we are going to continually improve by troubleshooting and looking at how we can do things better the next time round. Finally, looking at innovation and improvement. Now, there's a kind of an odd idea in paragraph 3.9 that JIT philosophy actually embraces failures. Now, that's a kind of a weird way of looking at this, but actually they see it as an opportunity to improve the process. So regardless of what the actual fault might be, then rather than thinking that it's something gone wrong, think about, well, how can we actually do it better next time? So this process of continual troubleshooting eventually leads to a series of small low-cost improvements, and these are referred to as Kaizen costing adjustments. So Kaizen costing is very much linked to this incremental troubleshooting reduction in cost. And we talked about the change in culture. This continual approach of troubleshooting will finally change the culture so that you've got a culture of constant analysis and improvement. And this links back to the idea that this is actually a philosophy. And if it's a philosophy, then everybody in the organisation really needs to take it on board. So the techniques in this chapter then, we're going to come back to these when we look at some other costing areas as we go through the other syllabus areas in P1.